Welcome everyone. Let me pull up the other screen here. We will get all set up. Give everyone a minute to come on in. All right, and we will go ahead and get started. So everyone, welcome to our first virtual Amos Star Party. This is part of the North Carolina Statewide Star Party, provided with support from the North Carolina Science Festival and Buncombe County Libraries. So welcome everyone, we're excited to get started. I'll begin by introducing our guest, which is Mr. Gary Lazich, maybe better known as Star Guy Gary. Gary began his journey as an astronomer at Northwestern University studying astronomy, but he later managed or worked at planetariums across the country for about 33 years before he retired. And now he spends countless hours volunteering his astronomy services around at community events, just like this one. So Gary's gonna run through two 15-minute presentations for us. He's gonna do one, the orb of night, and then the second, the one about the red planet. Each will last, like I said, about 15 minutes, but we are gonna take questions at the end of each one, so you can feel free to interact with us in the chat and we will make sure Gary gets those. And without any more talking from me, Gary, please take it away.
Thank you very much, Abby. I'm glad to be with all of you, if only virtually. It's still too early to see any stars outside, so to be true to my name, I thought I would bring the stars along. Actually, this was supposed to go off last Friday as part of the statewide star party, and we couldn't get the technology to work right, and the sky wasn't clear anyway. So we're still part of the statewide science festival. I do have two programs. The one is about 15 minutes. The second one is about 20 minutes. I hope you will indulge me on that. I think there's some good material there. And the first one, let me share my screen with you. There we go, is called The Orb of Night. And there we are. That's a poetic name for an object that we see in our sky. I believe the sky is going to be clear tonight, although it's going to be pretty windy and chilly. First off, I should make some acknowledgement. 10 years after Apollo 11, Mark Littman and the staff of the Hansen Planetarium created a planetarium program and booklet called Footsteps in honor of the Apollo moon flights. And I've taken some of my approach this evening from the approach that they took. If you were to go outside tonight and face south-southeast and look up fairly high in the sky, just to the west of the backward question mark called the sickle of Leo, you would see that bright object in the sky. It's the second brightest object in our sky. Had we seen it last Friday, it would have looked like this in binoculars. And of course, we can all agree on what that is, can't we? Of course, that's the moon. At least everybody except Obi-Wan Kenobi, who might say, that's no moon, it's a space station. But Crocodile Dundee might come along and say, that ain't a space station. There's a space station. The space station is an artificial satellite orbiting the Earth, like many, many others. The moon is our natural satellite, and we call it the moon because for hundreds and thousands of years, it was the only moon we knew. Now, of course, we know that there are dozens of moons elsewhere in the solar system, so properly, we ought to call this our moon. We think of the moon as very bright, but it turns out that the moon only reflects about 5% of the sunlight striking it. So if we can quote from Pink Floyd's Dark Side of the Moon, it is very true. Matter of fact, it's all dark, or at least nearly dark. We're all familiar with the apparent changes of shape that the moon goes through, what we call phases, or as Calvin and Hobbes once said, the moon is making faces at me. And his father said, no, that's phases. And it goes from new, when the moon and the earth and the sun line up, the moon is between the earth and the sun. We don't see any of the sunlit side. And it goes around to full when we see all of the sunlight side, and then back to new moon again. It turns out that that cycle of phases takes about 29.5 days. almost exactly 1 month, and that is where our word month comes from. Each of the full moons in a year has its own name given to it by the Native Americans and by traditions such as the Old Farmer's Almanac. You see the title, though. Joseph Brookshack wrote a book called 13 Moons on Turtle's Back. It turns out there are 13 full moons in a typical year. We call the 13th moon the blue moon. And it doesn't happen all that often, but often enough that when we say it only happens once in a blue moon, that means it happens fairly regularly. Early on, as we observed the moon, we tried to understand it, and we told stories about it as well as we could. And the first thing we noticed is that there are dark markings on the moon. What do you see in the moon, in those dark markings? Many people see a man in the moon, 2 eyes, a nose, and a mouth. The Maasai of Africa thought that the sun and moon were man and woman and that long ago they were lovers. They went everywhere together until one day they had a violent quarrel and the sun scratched the moon. Then they went their separate ways. Whenever the moon comes close to the sun in the sky, she hides her face in darkness. And whenever the moon does so, the sun is so embarrassed by his cruelty that he blushes red and as quickly as he can sinks out of sight beneath the horizon. One Native American nation saw 2 frogs in the moon, one on the right and one on the left. And the Chinese often look for a rabbit. Yeah, it does kind of look like a rabbit, doesn't it? Now, one of the Native American nations told this story about how Coyote once was the moon. The Great Spirit was looking for somebody to mind the moon, and Coyote, being the shy sort that he is, stood up and jumped up and down and insisted that he should be the moon until finally the Great Spirit granted his wish. Well, Coyote wasted no time into poking his nose into everybody's affairs and telling everybody about them. And there was such a hue and cry that the Great Spirit finally removed Coyote from the moon. And ever since then, whenever Coyote sees the moon in the sky, he howls. The Greeks saw Selene, their goddess of the moon, while the Romans saw Diana. The crescent moon was supposed to be the bow of her bow and arrow. Eventually, our imaginations became more sophisticated and we developed science fiction and fantasy stories. And it's not surprising that we do so. Sometimes when you see the full moon rising, it looks as though you could just reach out and touch it. One early idea about going to the moon said that we could take a boat there and travel across the ocean of space. One who decided that he would visit the moon by rigging 47 rockets to his favorite chair and having 47 assistants light it. There was a tremendous explosion, and when the smoke cleared, Wan Hu was gone. Did he make it to the moon? Well, the Chinese story says that he went to visit his ancestors. Johannes Kepler, the famous astronomer, wrote one of the first science fiction novels about a dream of going to the moon and visiting its inhabitants. He had to cast it in the form of a dream because if he had said that it was a matter of fact, he might have been tried for witchcraft. Edmond Rostand, in his work Cyrano de Bergerac, came up with several methods for getting to the moon, including one that involved hiding sacks of dew to yourself, and then when the sun rises in the east in the morning, the dew would rise and lift you to the moon. In mid-1800s, the New York Herald published a story purporting that John Herschel, an astronomer in South Africa, had discovered strange creatures on the moon. Well, John Herschel finally got wind of that and he put paid to that. Jules Verne wrote From the Earth to the Moon. The astronauts made their way to the moon in a capsule called Columbiad actually, and they were shot there by a giant cannon from a location in Central Florida. very nearby where Cape Canaveral is today. H.G. Wells talked about the first men in the moon. The astronauts made their way there by an anti-gravity substance called cavorite, and they discovered that there were inhabitants on the moon that they called selenites. This was later made into a Technicolor motion picture. And George Pal gave us Destination Moon, a realistic portrayal of what rocket flight to the moon might be like. In the mid-60s, Heinlein wrote, "The moon is a harsh mistress." Well, he was certainly right there. There's no air on the moon. There's no water. It is, in fact, a very harsh mistress. And then Stanley Kubrick gave us 2001, A Space Odyssey, a view of the moon in the future. You can see a lunar shuttle flying over the surface. And here they are making their way to the monolith they discovered under the surface of the moon because of its strong magnetic field. Once the sun hit it, it sent an alarm off to Jupiter, and that's what sent the spacecraft and the two astronauts out there. You notice that all the features appear very sharp and distinct, and that was the common idea about what the moon would be like. We would be surprised when we finally made it to the moon. Now, all the while all this imagining was going on, the scientists were trying to figure out what the moon was really like, and the artists were trying to depict what the scientists had learned. Here's one of Galileo's sketches of the moon. This was another reason why the church persecuted him, because at the time, the Catholic Church believed that the moon was perfect. It was in heaven after all, and that's what Aristotle had taught. And Galileo's observations through a telescope showed that it wasn't perfect after all. The French astronomer Cassini in the late 1600s did this very detailed map of the moon. You can see all those holes that we call craters and those dark areas. At the time, we thought that they may have been bodies of water, so they were called maria, mare in single, which is the Italian word for seas. Here's a view from the 1700s, again, benefit of the telescope. And this painting looks almost as though it could have been a photograph through a telescope from the 1800s. As astronomers observed the moon, they noticed something peculiar. Every now and then, it would pass in front of a bright star or planet. In this picture, in front of the planet Mars. You notice that the planet Mars is very sharp right up to the edge of the moon. That means there's no air there. If there's no air, there's no water, and there's nothing to hold the heat from the sun in, or to protect you from the heat from the sun. So at noon, the temperature is hot enough to boil water, and at lunar midnight, it goes down to 250 degrees below zero. Beginning in the 1920s, we weren't content just to show what the moon looked like, but to show what other things would look like from the moon. This is the Earth as seen from the moon in a 1920s painting. Lucien Rudeau, the French artist, depicted what a total solar eclipse would look like from the surface of the moon. On Earth, this would be considered a total lunar eclipse. And Chesley Bonestell showed that not only was the moon a world that we could picture, it was a world that we could visit with our rocket ships. And so began our exploration of the moon as a physical body. Robert Goddard invented the first liquid fuel rocket and the first multi-stage rocket, and showed how we could make our way from the Earth to the moon and back again. In the 1950s, Wernher von Braun picked up his ideas and developed the Saturn V rocket that would take astronauts to the moon. And John Kennedy put our feet on that path by declaring to Congress, "I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth." But first we had to do some reconnaissance. Ranger 7 crashed into the moon and gave us very highly detailed photographs before it did so. Surveyor landed and proved something that we really didn't know. Many people thought that the dust on the lunar surface might be so thick and soft that any spacecraft that landed on it would sink into it like quicksand. Well, Surveyor proved that that wasn't the case. And Lunar Orbiter gave us some close-up views from very different angles. This is the crater Copernicus. It's 120 miles across. But there was at least one stumble on the way to the moon. During a launch test of the command module, a fire broke out inside the capsule, sparked by a short circuit. There was a pure oxygen atmosphere inside, so the fire ran away and the hatch was very difficult to open from the inside. And so the 3 astronauts perished, Grissom, White, and Chaffee. But we continued on. In 1968, Apollo 8 went into orbit around the moon, gave us our first view of what the Earth really did look like from the moon, and read us out of the book of Genesis in the Bible on Christmas Eve. Apollo 10 came so close to landing on the moon. This was the test run to make sure that we could operate the lunar module properly. And then finally, on July 20th, 1969, the Apollo 11 lunar module landed, and Neil Armstrong reported to Mission Control, the Eagle has landed. And the Capcom, the capsule communicator, gave back, Roger, tranquility, you got a bunch of guys about to turn blue, we're breathing again, thanks a lot. They landed with less than 30 seconds of fuel left before they would have had to abort their landing. Now, who do you suppose this is? Many people think it's Neil Armstrong, but it's not. It's actually Buzz Aldrin. You can see the reflection of Neil Armstrong in Buzz Aldrin's visor, along with the lunar module. So we don't see any of the actual people involved. We see all the technology that get there, and they represent the tip of an iceberg of thousands of people that worked to get people to the moon. The Apollo 12 astronauts paid a visit to Surveyor 3 to see how it had been doing on the moon. Apollo 13 almost, but didn't quite make it to the moon. There was an explosion en route to the moon. They needed to use the lunar module as a kind of lifeboat. They swung around the moon using the moon's gravity to propel them back to the Earth, and they barely made it back safely. Apollo 14 is notable for the first golf shot on the moon made by Alan Shepard. You can see where the balls landed, and you can see the divots that were made by his shots. With Apollo 15, we increased our range by bringing along an electric vehicle called the Lunar Rover, the Lunar Roving Vehicle. And here you see in Apollo 16 doing the Lunar Rover doing laps around the launch site. It actually got up to a speed of a dozen miles an hour or more. And finally, there was Apollo 17. There should have been an Apollo 18, 19, and 20, but interest in the moon and lunar exploration had waned so much, and concern over things like the Vietnam War, that NASA canceled the last 3 missions. So Apollo 17 was the last piloted mission to the moon. And these footsteps that they left, because there's no air or water on the moon, may last 1 million years. So what did we learn from the Apollo missions? They brought back hundreds of pounds of rock and thousands of photographs. And by analyzing all of those, we began to understand what the moon was made of and where it had come from. The Maria obviously weren't bodies of water. They were places where asteroids had smashed into the moon and caused molten rock to flow out that later cooled and darkened and hardened. And the holes were craters created by smaller pieces of rock called meteorites. But what was the relationship between the Earth and the moon? Was the moon Earth's sister? Did they develop about the same time? Was the moon Earth's daughter? Did the moon come from the Earth as the Earth was forming? Or did the Earth capture the moon as a kind of a wife? We found out the real answer by analyzing the rocks. Earth and moon have rocks that are similar, but not identical. There are some things on the moon that we don't find on the Earth, and vice versa. And by analyzing those, we came up with an idea that billions of years ago, an object about the size of Mars must have struck the Earth while it was still molten, blasted off material from the Earth that formed a ring around the Earth that later coalesced to form the moon. We no longer send people to the moon. We don't have a way of doing that right now. The Saturn V rocket was the only rocket we had that could make it that far. So instead, we continue to send unpiloted space probes. Clementine mapped the moon and mapped its geology in 1994. Lunar Prospector in 98 discovered something very intriguing. You see those dark purple and red and blue areas. These are areas around the north and south pole of the moon, and the dark blue colors indicates frozen water ice. We said that there was no water on the moon. Well, that's not quite true. We discovered it at the poles. It's so cold there all the time that the water never evaporates. An Indian spacecraft provided further evidence of this. On the right, you see an infrared view of an area of the pole. All those blue patches that you see are patches of frozen water ice. Lunar Reconnaissance Orbiter continued to map the moon in high detail. And for those that claim that we never actually made it to the moon, that we faked it, this photograph shows that that's not the case. You can actually see from orbit the Challenger, the lunar module for Apollo 17. You can see the lunar rover where it was finally resting, and you can see all the tracks that were left as the lunar rover made its way on the lunar surface. Alcross in 2009 was a suicide mission. One of the spacecraft smashed into the south pole of the moon, and astronomers that studied that impact saw this puff of what looks like smoke coming out of that crater. That's not smoke, that's water vapor. The collision of the spacecraft vaporized the frozen water that was there and created this steam cloud. Most recently, other people have got into the act of exploring the moon, including the Chinese, who retrieved some samples from the moon and brought them back to the Earth for study. So where do we go from here? Is there a future for us on the moon? Many people think there is. We might create villages on the moon where people would stay not just for a few days like the Apollo astronauts, but for weeks and months and perhaps even years at a time. We might develop a lunar mining operation. It turns out that the moon is very rich in titanium, aluminum, and magnesium, the lightweight metals that we like to make spacecraft out of. The moon would be an ideal location for a radio telescope. Put it on the side of the moon that's always facing away from the Earth, and you have no trouble with radio interference. So things would be very quiet. And finally, the moon makes an ideal launching pad. The gravity on the moon is only 1/6 that of Earth, so you need far less energy to get off the surface. And we could not only build rockets using lunar materials, but actually launch them from the surface of the moon to other objects in our solar system, like Mars. Any questions in the chat about our orb of night?
We do not, but I would love to, if you could just touch on, before we move to Mars, what are the benefits of studying the moon? Why is it so important for us to understand what's on the surface?
Well, as I've said, we discovered that there's lots of lightweight metal there that we build spacecraft out of. And also it is an ideal launching pad. It takes us a tremendous amount of energy to launch things from the surface of the Earth, even into Earth orbit, let alone to another body of the solar system. The moon is a much more convenient launch pad. And in terms of how NASA right now thinks of it, the moon is our test bed for going on to places like Mars. We can learn how to live for long periods of time under very harsh conditions.
Awesome. Well, take us away to Mars.
All right. Let me change out. There we go. This is its most common nickname, the red planet. And once again, I have an acknowledgement. In 1988, when Earth and Mars were especially close, a company called Loch Ness Productions created a program called the Mars Show for planetariums, and we helped to premiere that at the Bueller Planetarium in South Florida. It's gone through several revisions that we've learned more and more, and now it's called Mars Quest. Once again, if you go outside tonight after sunset and look midway up in the west, you'll see a bright point of light that is not twinkling like the stars are. And you'll probably notice that it has a pink-orange tint to its light. The stars Betelgeuse and Aldebaran also have that tint, but they'll be twinkling, and that object will be shining very steadily. That is the target of our inquiry, Mars. And somebody may say, Mars? I thought that was a candy bar. Well, the candy bar is named after Mars, not the other way around. Once again, early on, we had nothing but our imagination and a very little bit of observation, and so we began to tell stories about Mars. And there are good reasons why we did so. Every couple of years, every 26 months, Mars looks especially bright in our sky when Earth and Mars are as close together as they can be. And at that time, Mars does something peculiar. Earth is closer to the sun than Mars is, so it passes up Mars in its orbit. And as Earth does so, Mars appears to go into a kind of backward loop. Instead of appearing farther to the east night to night, it stops and then appears farther to the west and then stops again and appears farther to the east. Because of its red-orange color, its pink-orange color, and because of these very dramatic movements, it's not surprising that we associate Mars with war. The Egyptian god of warriors, Horus, was their representation of Mars. The Greeks had Ares, their god of war, and the Romans, Mars, from which the name of the planet comes from. As our imaginations developed, we began to venture into science fiction and fantasy, fueled by what little we could learn about Mars early on. This was the first sketch of Mars. Not much to look at, but in fact, that's a fairly accurate representation of a dark area on Mars called Syrtis Major. Here's the first painting of Mars in the 1800s. You can see how much we've gained just by using larger and larger telescopes and better optics. But then there was a sharp left turn. In the late 1800s, an Italian astronomer thought that he saw on the surface of Mars what he called canali. Now, canali, when you translate it into English, means channels or grooves. But if you transliterate it, in other words, if you drop the I, then canali becomes canals, which implies some kind of intelligent design. And Percival Lowell had a field day with that concept. He mapped Mars full of canals that would carry the water from the poles to the dry areas on the equator. And he was convinced that they were signs of intelligent life on Mars. As Carl Sagan put, this is certainly true. The only open question was which side of the telescope the intelligence was on, because nobody else saw these canals. They saw some dark blobbed markings that you could perhaps connect with lines, but there were straight lines and canals all over Percival Lowell's maps. Well, of course, the thought that there were inhabitants on Mars led to the idea that perhaps if they were running out of water, they had better come to our world and capture us. So that's where the War of the Worlds came from by H.G. Wells. A much calmer, gentler vision of Mars came from Edgar Rice Burroughs. John Carter was an adventurer that made his way to Mars and became a warlord. He won the hand of Princess Dejah Thoris, Princess of Helium. He fought alongside a huge fighting creature called Tars Tarkas. Well, Pretty fanciful, yes. But 30 years later, an 8-year-old boy named Carl Sagan read those tales and was transfixed. He would go out into an open field, raising his arms like John Carter did, and imploring what he believed to be Mars to transport him there. It never worked, but there was another way. Much later in Cosmos, he would say that the visions of Percival Lowell and Edgar Rice Burroughs had this benefit, that they convinced generations of 8-year-olds, himself among them, that the exploration of planets was a real possibility. But first, I guess we had to work through our demons. On Halloween night in 1938, Orson Welles frightened the country with fictitious news bulletins that kept interrupting a music program about cylinders that landed in New Jersey, out of which came machines that incinerated everything in their path. In 1950, Ray Bradbury told a series of parables about Mars, indicating that once we made our way to Mars, the Martians might suffer the same fate as the Native Americans once had, eliminated by ignorance and violence and disease. And who could forget Marvin Martian? If there were such a creature on Mars and we began to invade it, if only with robot spacecraft, he might well say, "Oh, now you've made me very angry." We had The War of the Worlds as a film in 1953. Spectacular special effects, but quite violent. And an old tale gets a new spin in 1964 with Robinson Crusoe on Mars. Who could forget Total Recall, where a construction worker thinks that he's going to go through a manufactured fantasy and discovers, or at least thinks, that he's really a secret agent with responsibility for setting Mars free from its dictatorship and setting its atmosphere free to turn it into a version of the Earth. Kim Stanley Robinson had a similar idea, creating a widespread planting of green plants on Mars that would later turn the sky blue. So he had red Mars, green Mars, and blue Mars. The War of the Worlds again, Steven Spielberg's version of the story. And Jeff Wayne's musical version of War of the Worlds. The chances of anything coming from Mars are 1,000,000 to 1, he said. So said the astronomer. Disney weighed in with Mars Needs Moms. Well, yeah, I suppose so. And there was the astronaut that was left behind, Matt Damon in The Martian. And National Geographic weighed in with a TV series about what settlement of Mars might be like. And finally, we had the story of the boy from Mars, the first child born on Mars who comes to the Earth for the first time and falls in love with an Earth girl. Well, these are all very fanciful stories, but they're made more of imagination than fact, and science is concerned about facts, and science art is concerned about factual representation. So how did they conceive of Mars? Well, we learned that the Mars orbit obviously is much larger than the Earth. The Mars year is 1.9 Earth years. It's somewhat lopsided, so when Earth, the Sun, and Mars line up, sometimes it's farther away and sometimes it's closer. At perihelic opposition, when Mars is closest to the Sun and Earth is farthest, the two planets are separated by only 35 million miles. By comparison, the moon is about 250,000 miles away. Mars is half the size of Earth, but if you don't count the oceans, on Earth, it turns out that both planets have the same land area. Mars spins the same way that Earth does, and its day is only 20 minutes shorter than ours. And the axis around which it spins is tilted almost exactly the same way that the Earth's is, which means that Mars has seasons, although they're twice as long as the ones on the Earth. The North Pole of the Earth turns out to be made almost entirely of dry ice, frozen carbon dioxide. But the South Pole, the residual South Pole after the melt in the summer, is made of water ice. Of course, there's no air to breathe and very little of any kind of gas there. The surface pressure is less than 1% that of Earth, and it's all carbon dioxide. Mars does have weather like the Earth's, but it's driven by dust rather than by water. You've heard of the dust bowl on Earth? At times, Mars becomes the dust planet. A global dust storm covers all of the surface features so that as seen from Earth, there's nothing visible. Mars has 2 tiny moons, so small that we think they're captured asteroids. And this is where the artists come in. This is Chesley Bonestell's view of Mars from Deimos, which is farther out than Phobos. And here we're close in at Phobos. Bonestell combined with Willy Ley and Werner von Braun to create a book, illustrate a book called The Exploration of Mars. Why stop at the moon, they thought. We can use the same technology that we would develop to get to the moon to get to Mars. Here's a Martian landscape as shown by Bonestell. Notice the color of the sky. And here his understanding of how we might explore Mars, not only with rockets, but with planes soaring over its surface. Well, it wasn't enough to imagine or to learn about Mars and depict it. We had to go there to find out what it was really like. The first flyby showed us craters. The second flyby showed us craters. The third flyby showed us craters. It began to look as though Mars was a dead world like the moon. Well, that couldn't be right. Mariner 9 arrived in the middle of a planet-wide dust storm. You can see 3 of the 4 spots that the spacecraft could see through the dust. They turned out to be huge volcanoes, and the largest, Olympus Mons, is as wide as Arizona. There was also a huge canyon as long as the United States is wide, Valles Marineris. True, there were craters, so obviously Mars had been impacted by things, but there were other things that were quite intriguing. This, for all the world, looks like a dry lake bed where there used to be liquid water. And this looks like a stream channel on Earth where water must have run at some point. Well, we needed to find out more, not just to fly by, but to orbit the planet and to land on its surface. And this is the first view of the Martian surface given to us by the Viking 1 lander. It came into us a strip at a time, and I remember watching as the spacecraft made its transmissions, and finally we see the footpad there on the surface. Obviously, it didn't sink. Here's the first color view of Mars from the surface. Of course, it has a blue sky, doesn't it? Earth has a blue sky after all. But then somebody looked at the color calibration disk on the spacecraft and said, that's all wrong. And when they set the color to match the color calibration disk, the sky was pink, tinted by Martian dust, suspended in the very thin atmosphere. We wanted to know if there was anything alive on Mars, so we dug trenches into its soil and dumped the soil samples into a makeshift laboratory to see if we could find any signs of life. And we found some very active chemistry that looked as though it might have been caused by life, but there was no organic chemistry, none of the materials that life would have created. But there was frost in the Martian winter, and every day there was a sunset. This is the first picture of sunset from another world. The Viking 2 orbiter had the same kind of mission, an orbiter and a lander. Here's the Viking 2 lander in Utopia Planitia. The orbiters continued to do reconnaissance of the surface. This is Olympus Mons as seen from above. and here at an angle with water vapor, ice vapor clouds around it. And there were stream channels everywhere. It looked as though there must have been some kind of liquid water that ran on Mars. Where did it all go? There were more dust storms, of course. So as a result of these spacecraft missions, we got some answers, but that raised more questions. Mars Global Surveyors showed us what looked like a stream of water running down the side of a crater, leaving deposits. Mars Pathfinder gave us the first rover, Sojourner. You can see it next to that rock there. Here's a closer view of that. It actually drilled into the rocks and sampled the rocks to see what they were made of. Our next two rovers, Spirit and Opportunity, landed in Gusev Crater and Eagle Crater. They were supposed to last 3 months on the surface. They lasted for years before they finally succumbed to the dust in Mars and no longer received solar power from the sun. The Mars Reconnaissance Orbiter showed us our first views of dust devils on the surface of Mars, spiraling along the surface, as well as sand dunes. Phoenix dug into the soil and discovered a white layer under the soil. That's water ice. So that's one answer to the question of where the water went on Mars. It's frozen under the surface and in the polar caps. The rest of it must have escaped because Mars has a weaker gravity and the radiation of the sun caused it to evaporate away. Curiosity landed in Gale Crater and discovered something we'd never seen before. Scientists nicknamed them blueberries. These are tiny spheres of clay, water concretions. They only form in the presence of liquid water. So at the time that they formed, they had to have been liquid water. MAVEN analyzed the atmosphere. It turns out that there's more methane in the atmosphere than we can explain with other physical processes. And one explanation of methane is the presence of life. We haven't found any other evidence, but we're still studying where this methane may have come from. InSight landed in Elysium Planitia once again. Here are the landing sites on Mars in a map form. We've explored the planet, so it would seem, fairly well, and yet there's a lot of area that we haven't covered yet. Not only that, it's very hard to get to Mars. This is a map of all of the missions to Mars up through 2018. Only half of them have succeeded. Here's a view of Mount Mercou in Gale Crater. This is one of the most dramatic images returned to us from the surface of Mars. Just to look at it, you would think that we were in the southwest of the United States, except for the pink sky. So Earth and Mars, in some respects, are very similar. And most recently, how many of you have watched as Perseverance landed on the surface of Mars? Whoops. And Ingenuity has now flown a little bit above the surface. So we put all this together, and our best understanding of Mars says that billions of years ago, there were oceans and streams and lakes on Mars when Mars was a warmer and wetter place. But most of the water escaped to space, and the rest of it went underground at the poles primarily. And so now Mars is a dry, cold, and dusty world. What are the prospects of colonization for this world? It's a lot farther away than the moon, but it's more similar to the Earth than the moon is. So in some ways, we have some advantages. Who will take the first step? Well, the first step may well be made by a woman. Perhaps she will say that's one small step for a woman, one giant leap for humankind. There's a group now active called the Mars generation, sort of the next generation of Martian explorers made of young men and women. It was founded by astronaut hopeful Abby Harrison. She's only 24. She's not too old to go to Mars. She's not an astronaut yet, but if she keeps at what she's doing, she will be. One of the members of the Mars generation is Alyssa Carson, 13. She's certainly not too old to go to Mars. Would one of these young women make the first steps on Mars? Or perhaps it will be one of you. Will it be Carolyn Collins Peterson? Well, I think not. She's too old. But she was the one that wrote the Mars show, which became Mars Quest. And she has given me permission to read the ending of that show to give you some idea of what one vision of Martian colonization might be like. The original program was narrated by Patrick Stewart. You may know him as Captain Jean-Luc Picard in Star Trek: The Next Generation. I'm no Patrick Stewart, but I think the words are compelling enough combined with the images to give you some idea of how I felt when I first saw the premiere of the ending of the Mars show. Mars. A philosopher once called you a metaphor for the future of the human race. You couldn't be less like Earth, and existence on your surface has never been easy. But always we dreamed of walking your dusty plains. Our first steps were small ones, taken by robotic probes that stirred your surface and sniffed your atmosphere. The efforts of our early explorations were too expensive for one nation to bear alone. The peoples of Earth began to cooperate, scientifically, politically, and socially. It was as though all of the centuries of evolution and intellectual growth had brought humans to the moment when they were finally ready to make the leap from the home planet. They were ready to go. 21st century Martians destined to change the history of the solar system. The hopes of humanity followed those explorers across the gulfs of interplanetary space. And when they took their first steps onto the Martian surface, it was the end of an old era and the beginning of a new. Mars. In the infancy of humanity, we feared you as a god of war. Then we strove to learn your mysteries and conquer your beautiful desolation. Finally, the restless wanderers among us made you our second home. Earth is now a fading memory of a watery blue planet shining in our night sky. But our Martian cities stand as a tribute to all the dreamers of Earth. Now, we are the Martians. I think I can stop sharing now.
Wonderful. And I think you did a great job narrating that. I'm imagining if we were in a planetarium right now and everything and the lights went off right as you closed, I can see it.
Yes, it's really made for a planetarium. There were a couple of panoramas and there were Martian machines, mining machines going. And at the last, when we see the city, there's a shuttlecraft flying to the city.
And so you're not going to get away without any questions. So let's start with, why do stars twinkle and planets don't?
Stars twinkle and planets don't because planets are very, very much closer to us than stars are. Stars are just points of light. And as those points of light shine through our atmosphere, the shifting hot and cold air currents make the light appear to twinkle and sparkle. The planets are close enough that they're not points of light, they're actual disks, even though our eyes can't see them without a telescope. And so this twinkling that would happen gets smeared out over the disk and they shine very steadily.
And Lily, who is 4, would like to know, how do rocket ships blast off?
There's a very simple principle behind it that Isaac Newton came up with 400 years ago. To every action, there was an equal and opposite reaction. Rockets, the way we use them now, depend on some kind of explosive force, getting liquid oxygen and liquid hydrogen together, they make an explosion, and the rocket contains the explosion except out the end, the nozzle. So as all of those gases and force goes out the nozzle, the reaction is that the rocket ascends.
And so why is the sky pink on Mars? Is it the composition of the atmosphere?
It is. What you're seeing on Mars is the suspension of Martian dust in the very thin air, and that's why it gives it that pink view. The only time that the air around Mars gets anything like blue is right around sunrise and sunset.
And Gary, would you go to Mars if age weren't a factor? Would you go to Mars and colonize?
People have asked me a similar question about, would you go into orbit? Would you go on the space station? I think I would make a very poor astronaut, not only because I am old and have some health conditions, but also because if I went to the space station, I'd probably spend all my time in the cupola gazing down at Earth, and I wouldn't get any of my work done. You want somebody that has a very clear sense of a mission, some things to accomplish that you have to do, regardless of how you feel about what you're doing. So in that sense, I don't think I would make a good astronaut for Mars. And yet, thanks to planetarium programs like the Mars Quest, I know what it would be like to stand on the surface of Mars and see what they will see.
And you hinted at a lot of evidence of potential life, right? But we've never actually discovered life on other planets yet. And so what was the new development about Venus? There was like potential life signatures on Venus. Can you talk about that for a minute?
Yes. Some scientists discovered a gas called phosphine in the Venus atmosphere. And one way to generate phosphine, in fact, really the only good way, is as a result of processes of living things. So immediately people wanted to jump to the conclusion that if there's phosphine in Venus, there must be something alive. Well, science proceeds very carefully. Just because they observed it, now other scientists are looking to see if they can observe it. They're trying to come up with some other processes that could generate phosphine. It's intriguing, and that's why we want to find out more about it. But we're not at the point yet of saying, yeah, there's life on Venus or life on Mars.
And what advice would you give to young stargazers?
Be curious. Go outside whenever it's clear and whenever you can afford the time. Look up, wonder, read everything you can about it. As you go through your studies, eventually you can make the choice to learn science and mathematics and engineering and even art to prepare yourself to become one of these future Mars explorers. My degree at Northwestern dates back to 1975, but I've been interested in the sky since I was at least 4, if not earlier. So all the while I was trying to find out about things. And I discovered at Northwestern that I didn't have the temperament to be an observational astronomer, and I didn't have the thinking skills to be a theoretical astronomer, but I was excited about what they were doing and I could communicate that to people.
Yeah. And I am so hoping that to add to that we are going to have our next star party, hopefully in person, so we can get some kids looking into some telescopes, because I will just say that is obviously not everyone has access to a telescope, but that is a great way to get very invested. And also a planisphere. So let's predict where the stars and the planets are going to be next in our sky. I always like that one too.
Yes. If you query the astronauts, many, if not most of them, will say that they became interested in space either because of looking through a telescope or going to a planetarium. So it is very important to get, we can look at pictures all day, but when you have your eye at the eyepiece of the telescope and that light from Mars, for example, is coming right through the telescope to your eye, there's nothing that can match that.
And one last question before we end this wonderful star party. Gary, what is the one space advancement or discovery that you hope to see in your lifetime?
That's a tough question and a good question. I guess I would like to see an answer to the question of whether or not there's life out there, whether it's in Venus or Mars or in a planet around some other star. All we have to do is find one instance. And if we found that one instance, that leads us to believe that there are perhaps thousands of instances elsewhere. And then we find that we're not alone, that there are other living, intelligent beings out there. It's one of the most profound questions that science can answer. And Arthur C. Clarke years ago said, whether we find out that there's life in the universe besides us, or whether we find out that we're the only life, the consequences are staggering.
Love it. Let's leave it there. That was a beautiful way to end.
Okay.
And thank you everyone so much for watching. Gary, thank you so much for spending your evening with us. As I mentioned in the beginning, Gary comes in and volunteers a lot of his time with Amos, talking to people about space and the cosmos and anything. He can answer pretty much anything you throw at him. So I welcome you all to come visit Gary sometime. All right. And we will.
One final thing, we are working to get some kind of sky tours going in Amos again. The pandemic shut the Star Dome down, and we're working on a couple of other alternatives. So hopefully when you come in, I won't just have things to tell you, but I'll have something to show you.
Yes, absolutely. So keep your eye out for it, and we will see you all next time. Bye, everyone.
Bye now.